Let's try another. The integral of x to the fifth over x squared plus 1 with respect to x. Now the obvious substitution here is the thing on the bottom of that fraction, x squared plus 1. So then du dx is going to be 2x. Okay, so my integral is, I want 1 over u times du dx, which is 2x with respect to x. I had x to the fifth, I've now got 2x, so I've still got x to the fourth here, that's one of the x's came out, and I've got 2 here, so I want a half of that. Okay, so far so good. Let me put my substitution in, half of the integral of x to the fourth, 1 over u du dx dx, which is a half of x to the fourth, 1 over u du. But the problem is I've still got x to the fourth here. Can I write x to the power of 4 in terms of u? Well, yes, I can. This tells me that, I'm going to do this, u minus 1 is x squared. So u minus 1 squared is x to the power of 4. And I can substitute this in here. I've got a half of the integral of x to the 4 is u minus 1 squared over u with respect to u. Now, this is still a quotient and it's not easy to integrate. But I can expand these brackets, same trick as last time. Half of the integral of, this is u squared minus 2u plus 1 over u du. And now I can distribute this u on the bottom. It's the integral of u squared on u is u on u is 1 over u with respect to u. Now, you can put brackets around that if you want to. I'm now ready to do the integration. So, it's a half of, the integral of u is u squared on 2, the integral of 2 is 2u, and the integral of 1 over u is ln mod u, plus constant. Now I have an answer in terms of u, but of course I want an answer in terms of x. So u is x squared plus 1. It's a half of, this is x squared plus 1 squared on 2, 2x squared plus 1, ln mod x squared plus 1, plus constant. Now it is actually possible to simplify this a little bit more. It gets a bit messy. The first time I tried it I made a mistake. The textbook also made a mistake when they did this. I'm going to have another go. So we have this. And my pen's decided not to work. There we go. What I'm going to do is two things first. I'm going to distribute this half to each of those terms. And I'm going to rewrite this, not very different. X squared plus 1 is always positive. So instead of the absolute value, I'm just going to use normal brackets. Let's do that first. It's, oh, I didn't want to do it that way at all, did I? I wanted to put the half inside. So, it's x squared plus 1 squared over 4 minus 2 times a half is x squared plus 1 plus half of this is ln x squared plus 1 over 2 plus constant. So I've just put the half inside each term, and I've rewritten this without the absolute value. It's a little bit simpler. But we're not done yet. It is actually possible to simplify this some more. Now, you don't have to. Either of these are perfectly valid answers to the question. But my curiosity gets the better of me, and I want to try to see what happens if I expand these brackets. If this was, power of 4 or 5, I wouldn't bother doing this. But because it's power of 2 only, I think I'm going to be able to simplify this by changing my constant. Let me show you. Expand the brackets. X squared plus 2x plus 1 on 4 minus x squared minus 1 plus ln x squared plus 1 over 2 plus constant. Now, let's do this carefully. All the constant terms I'm just going to leave to the end. I have here x squared on 4 minus x squared. So that's minus 3x squared on 4, minus 3/4. Then I have, in fact, I might even cross those out to show it, remind myself I've done that. I've then got 2x on 4, which is x on 2. Then I've got this term I can't do much about, ln x squared plus 1 on 2. But now look, I've got a quarter and minus 1 and a constant. So I can in fact just make it a new constant instead. If you want, you could even declare the value of that constant, where C1 is the old C plus a quarter minus 1. But it doesn't really matter. It's just another constant. And when I'm integrating, it's some constant I'll decide later. And this, you see, is definitely simpler than this. And that's why, if it's just a low power, I might consider doing this. You might prefer to write these as fractions. You could write -3/4 x squared plus half x plus half ln x squared plus 1. Doesn't really matter which way you do that. But I did want to show you that although this is a perfectly good and perfectly valid answer, it is actually possible to simplify it a little bit more by expanding those brackets.